Owners of a bike rental company that charges customers between $8 and $12 a day to rent a bicycle have determined that the number of bikes rented can be modeled by a linear function, 250 minus 10 times P, where P is the daily rental charge. How much should the company charge each customer to maximize daily revenue? Seems like a reasonable thing to ask. I think we should untangle a bit of what we're being asked. Maximize revenue, that's my objective. And I hope you're starting to see the utility of always calling it omega. Omega exists to be optimized. And there's a constraint in this function as well. And the constraint is this $8 to $12 per day. That says that P is inside of 8 and 12. Why is it P? Because P is the daily rental charge, and we're charging $8 and $12 per day. So that must be a restriction on P. Now, as far as the objective function goes, think about it. Like, if you're selling gallons of milk, how much revenue do you generate by selling gallons of milk? It's the number of gallons you sold times the price per gallon. So the same thing is going to be true here, that revenue is going to be equal to the number of bikes rented times the price per bike. Thinking about that in terms of factor labeling, I'd have bikes canceling with 1 over bikes, which would just leave me with price or dollars left over as the unit of this measurement. In this function, we have that that's equal to 250 minus 10 times P times P. Okay, so that's my objective function, 250 minus 10, P, quantity times P. If we want to, we could write this as like minus 10P squared plus 250. Both forms are really nice. I like this one because it's factored and it tells me what the roots of my function are. So I believe in drawing pictures as a key part of solving problems like this. And the picture I'm going to draw in this case is a picture of the objective function. I'm going to start by drawing axes, and we'll note that I have a downward opening parabola. Its roots are at 0 and 25. So I've got a downward opening parabola whose roots are at 0 and 25. This is the revenue, and the unit of the vertical axis is dollars. The unit of the horizontal axis is bikes. We can conjecture then that the optimal value is going to lie halfway in between. Hopefully you're starting to see that pattern for problems that deal with parabolas. Let's find that value using calculus. So I need to find the critical points. We've got a parabola, and so there's going to be one critical point. Omega prime is going to be minus 20p. I'm missing a p, plus 250. And I'm going to set that equal to 0 because all of the critical points are going to be ones where the tangent line is horizontal. That means that 20p equals 250, which means that p equals 12.5. It's dollars per bike is what it is. That's the unit, dollars per bike. So if we charge $12.50 a bike, we make the most revenue. But we didn't take into account this range of prices that we wanted to charge. So this $12.50 per bike is not inside of my interval of validity that I'm considering. So we'll reject it. So we got to think about where the optimal values live. So let's identify on my graph down here where those values are. So my valid values are here between 8 and 12. And we can see by looking at the graph that the max on that interval is 12. This is a case where the critical point is outside of the domain of interest. The domain of interest in this case is 8 to 12. and the maximum value is going to occur over here. And if we wanted to see it non-graphically, we would evaluate our function at these two values, and we would find that the revenue for $12 per bike is greater than the revenue for $8 per bike. That's not always true for the greater amount. Say we were considering like 14 to 20, the greater revenue would be at 14. So you can't just take the bigger number, because then you've driven demand down because the bikes were too expensive. The revenue, omega of 12, is bigger than omega of 8. So the optimum price is $12 per bike. And what are we being asked when we go to conclude? How much should the company charge each customer per day? Okay, cool. That is exactly what I found right here. What I didn't get asked was like, what's the optimal revenue? In which case I would have taken this and fed it through my revenue function in order to get how much money we're taking in gross per day from renting bicycles. I will say that these problems I regard generally as relatively easy because they're generally upside down parabolas. And the key to doing these problems is that you just got to take the product of the number times the price. And that's the key to doing these problems successfully.